Okay, we will commence with the second lecture of week number 6. In the first lecture of the week, you were introduced to the properties of moist air that we work with in psychrometry, the definitions of those properties, how those properties can be determined by using equations, and also by using the psychrometric chart. We will start with an example in which we will make use of the equations and the psychrometric charts to find out some properties at a given state of moist air. Okay. So we start with the first example, in which the dry bulb temperature and humidity ratio are given at a barometric pressure of 101,325 pascals, and the relative humidity is required. So if you recall, the relative humidity, it can be obtained by taking the ratio of the existing partial pressure of water vapor in air, divide that by the partial pressure of water vapor in air when that air sample becomes saturated at the given dry bulb temperature. That means the first thing we need to obtain is the partial pressure of water vapor in the given sample, and that we can find out because the humidity ratio is given and the total pressure, that is the barometric pressure, is also given to us. And you start by the equation that we had arrived at earlier in the previous class, that is W is equal to 0.622 times PV upon P minus PV. All we have to do is to just rearrange this equation such that we can find out and the value of PV in terms of the known parameters, that is humidity ratio and barometric pressure. So you just cross multiply this over here, and when you cross multiply it, the resulting equation will be shown over here. And now what we can do, we can take the second term on the left hand side and move it onto the right hand side. We will take it over here onto the right hand side, and then what you can do, you can take the vapor pressure as common and you will get PV into 0.622 plus W, and on the other side you will have W times P. So PV will be W times P upon 0.622 plus W, and then we can simply insert the numerical values for the humidity ratio and the barometric pressure, and that gives us the partial pressure of water vapor in the existing sample, which comes out to be 1.1818 kilopascals. The next thing is PV sat, and we know that the dry bulb temperature of air is 30 degrees C. So when we need to find out PV sat, what we are saying is that at 30 degrees C, if the air is saturated, the water vapor will have a certain pressure which will be found out from table A1. So we look at table A1 at a dry bulb temperature of 30 degrees C. You can see the water vapor will also be at 30 degrees C, and when the air is saturated, it will exert a pressure of 4.241 kilopascals. So that is PV sat for the given dry bulb temperature. Substituting that value over here, we find out the relative humidity as 27.87%. So that is the required result. by using equations. The same we will find out by using the psychrometric chart. And when we move on to the psychrometric chart, do remember that the humidity ratio on ASHRAE psychrometric chart number 1 has units of grams per kilogram dry air. So need to convert the given humidity ratio from kilogram per kilogram dry air. So you just multiply it by 1000. That comes out to be 7.34 grams per kilogram dry air. And then now let's look at the psychrometric chart. And we will first locate a humidity ratio of 7.34 on the vertical scale. This is 7, this is 7.5, so 7.34 will be somewhere over here. So you will draw a horizontal line, and where it intersects the 30° C dry bulb temperature line, that is the state point. So I will just move this over here. And you can now see that the state point is identified over here, and we just need to read the relative humidity from the psychrometric chart. You can see the 20% relative humidity line over here. This is the 30% relative humidity line, and if I just through observation try to estimate the value over here, if we are somewhere in the center, this would be close to 25. So this is around 28% from observation. I would of course suggest to you to print out the psychrometric chart and use proper instruments, scale and set squares to obtain values from the psychrometric chart, which will be more accurate. So the 28% value, we can now just compare that with the calculated value, and which is quite acceptable. The calculated value was 27.87%, so if I through observation found it out to be 28%, that is acceptable. I will now move on to the second example, and this time we are given an air sample again at atmospheric pressure of 1 atmosphere with a certain dry bulb temperature and relative humidity. That means we can locate the state and then obtain the other properties which are asked in the question. First, again we will do so by using equations, and this time we will start with the relative humidity. The expression for relative humidity as before is PV upon PV sat into 100% as a percentage. So phi is given as 30%, and what we can do is first find out PV sat from the given dry bulb temperature. So P sat at 22° C will give us PV sat, and again that is obtained from table A1. Go back to table A1, and at 22° C we find that the saturation pressure, that is Psat, is 2.642 kilopascals. Substitute that value over here, and that will give us the value of the partial pressure of water vapor at the given state of 22 degrees C dry bulb temperature and 30% relative humidity, which comes out to be 0.7926 kilopascals. The next property that is required is the humidity ratio, and once we have the total pressure and the partial pressure of water vapor, it's a straightforward insertion of the values in the given expression, which has been done over here, and that gives you the humidity ratio of 0.0049 kilogram per kilogram dry air. The third property is the vapor density. Now if we recall the definition of humidity ratio, it is the ratio of mass of water vapor to the mass of dry air in the given air sample. The mass of water vapor can be written as the product of the density into the volume for both water vapor and air. Because the volume occupied by the water vapor and air is the same, it will cancel out in the numerator and in the denominator, and that will give you the humidity ratio as the ratio of the densities of water vapor to the density of dry air. And we had basically worked out the expression for specific volume of dry air in the previous class, which taken as the reciprocal will give you the density of air. So what I have done is simply substituted that expression over here, and you can refer to the previous lecture to see that the density of dry air will be PA, which is P minus PV, divided by the gas constant for air times the absolute temperature of air, and that is then multiplied with the humidity ratio. Now again you substitute the values in this expression, and that will give you the vapor density, which is 0.0058 kilogram per meter cube. Then the last property is the specific enthalpy of the mixture, and the specific enthalpy, the equation again you can refer to the previous expression, is H is equal to CPA times T. CP is the specific heat of air, with the value is 1 kilojoule per kilogram per Kelvin. T is the temperature in degrees C. W is the humidity ratio, and Hg is the enthalpy of saturated vapor at the given dry bulb temperature, which again is obtained from table A1. So we can again verify that the value of Hg, which is shown over here to be 2541.8 kilojoule per kilogram, is correct from the table. And at 22 degrees C we can just go to the enthalpies, and you can see over here 2541.8 is the value, and that gives you the specific enthalpy of the mixture, which comes out to be 34.45 kilojoule per kilogram dry air. And as before, we will use the psychrometric chart to obtain these results. The first step is to locate the state point by using the dry bulb temperature and relative humidity, which was 30%, and the dry bulb temperature is 22 degrees C. So 22 degrees C, this is 20, 21, 22. You go up, and where it intersects the 30% relative humidity line, that is the state of dry air over here. So that we have done. That was the first step. State of the air is shown on the psychrometric chart. I will first find out the humidity ratio. That is straightforward. That is, you go and just simply draw a horizontal line from the state point onto the vertical axis, and you can see that the humidity ratio is 5 grams per kilogram dry air. And again we can convert it into kilogram per kilogram dry air by dividing it by 1000, so that gives us 0.005 kilogram per kilogram dry air. Then to find out the vapor density, we can again go back to the equation that we had just used earlier, and instead of finding out the density of air, we can use the specific volume of air from the psychrometric chart. If you look at the constant specific volume lines, you can see the line that we have over here has a specific volume of 0.84 kilogram meter cube per kilogram dry air. And this is the line that will be read to find out the specific volume of the moist air sample over here. This is 0.84, this is going to be 0.85, so this is below 0.845. I would estimate it to be 0.843 by observation, and that is the value that I have shown over here for the specific volume of the moist air sample, and the specific volume of the dry air is the same. And that gives you the same value of the density of water vapor, that is around 0.0059 kilogram per meter cube. If you compare these two values that we have obtained so far with the previous ones, this we have found out to be 0.005, this is 0.0058, and we have got the value 0.0059. So although I've just used visual observation, we are still quite close to the calculated values from the equations. The next property is the specific enthalpy, and that we can again read from the psychrometric chart. We have to draw a line of constant enthalpy that passes through the state point, and then read the value of the enthalpy from the enthalpy scale. So I will choose any line as my reference line. For example, if I take this line over here, and then I will simply extend this line. We'll take this line over here and then read the specific enthalpy 32, 34, approximately 35 kilojoule per kilogram dry air, and you can see that value is given over here. And again compare it with the calculated value, which was 34.45. so if I've read it as 35 kilojoule per kilogram dry air, again that is acceptable.